G'day possums, welcome back to the lab. I have purchased a Hewlett-Packard signal generator, the HP8656A Signal. This is part 2, and in the previous episode you saw me replace the capacitors in the power supply, test and recalibrate it, but unfortunately I still have no output from this signal generator. So today we have a look at the attenuators and see if they've spat out their contacts. Electromechanical is always fun to fix. Enough talk, let's get started. To access the attenuators underneath, I remove the handles, then the side panel. The same process again on the other side. Flip the SigGen upside down. Then remove the bottom panel. I remove 11 nuts securing the bottom circuit board. Then 12 screws securing the attenuator shield. And a further 7 screws securing the bottom panel. I've just flicked our signal generator around. But here we have all our little attenuation chambers here. We've got 1, 2, 3, 4, 5. And basically when our radio frequency signal is generated, it comes in from this side and then goes through all these chambers and gets spat out up here. So basically we have almost like relay coils up through here, pushing in and out some little armatures or arms, and then they slide contacts in these chambers, and as those contacts slide in and out, they switch in various resistors and different components to make the actual signal larger or smaller. So with minimum attenuation, that means maximum output. It's basically straight through from here to here with hardly any attenuation or resistance. But when we after maximum attenuation, or the smaller signal coming out here, out on the plug on the front of the SIG generator, we basically have all the resistors and components switched in, making the signal smaller, 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 and smaller until there's hardly anything coming out here whatsoever. So what we need to do is we're just going to pop the lids on all these attenuation chambers just to make sure the electromechanicals are all hunky-dory in there, and we might just pop this one here, get the flat screwdriver underneath, pop it up, and we can see that chamber's okay, and the next lid's up and everything seems to be intact in here. And everything is still intact in here, and you can see the little components in here, and they're the resistors that kind of get switched in and out that make that signal smaller and smaller and smaller when you're after, you know, that maximum attenuation or resistance basically. And the actual contacts, actually the arm flicks underneath this plastic plate here, I gather, and then you've got little contacts underneath. So we'll just have a look. Keep going. Bingo. And we can see that this little attenuation chamber here is blowing its contacts or throwing them out, and with those contacts out, the signal basically stops here and will go no further. And that's our last chamber here, and that one seems to be okay, and then you can see where the signal goes straight out to that plug out the front. So we'll make a start at repairing this little contactor down in this chamber right here. We'll gently just remove these contacts, handle these very gently. They are so easy to get lost, and you can't buy replacement ones. Undo the screw. Nice and gentle. Out comes our washer. And if you have a look here, you'll see our little contacts go underneath that arm. So we'll put those in place right now. Just going to put our first contact in place. There we go. That's our first one. If you have a look at the side profile of these contacts, they're kind of a little bit like an M. And they're in the little hole there. So that should work quite nicely. And it looks like it's all gold in here as well, so they want absolutely no resistance when these contactors are flicking backwards and forwards. We've just put our little cam arm or arm under the microscope, and we just want to have a look at our little grommet here up the other end, and we can see it's still pliable. The rubber hasn't perished or it hasn't cracked, and this actually pops in to a little slot within the cam itself, which is directly connected to the contactor itself. And if this is perished, the actual arm won't move and it won't actually go into the slot correctly. So if you need to buy a new grommet, you'll have to go down to your local electronics store and get something that's 1/8 of an inch across or about 3 mil across, and then pop it over the top again. But this is in perfect condition. So all we have to do now is pop in its little home, its little slot, and get it locked in, and then we should be right to move on. This is the tricky bit. We're trying to get the arm back in its little slot. And just find that slot and just push through a little bit, give it a bit of a twist as we go. As you can see, I think we've got it. If we give it a slight push forward, it doesn't go any further. If we give it a slight pull back, it doesn't pop out. So that's the perfect position. And you can see we're nicely aligned here on our contacts. So if we have a look at the tweezers there, slight pull back and push, and that cams is locked in perfectly. We'll gently put this back in place. Nice and gently, there we go. Everything's all seated nicely. Washer in. Put our screw back down. And we'll gently tighten it up, but not too tight. Perfect. We're just checking our chambers, just either side of where we repaired the original contacts. And if we have a look here, we have our first 3 chambers exposed. And We're just checking for two things. We're checking that all our contacts are present. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're actually checking the arms that just pop out of those cams. And we're making sure that those arms are locked in properly. Get our tweezers, give it a slight tug in this direction, a slight push back. And we know that that grommet is locked in okay. And the same for all the rest. Push forward, and pull back. That one's fine. Gives this one a bit of a yank. Not a problem. Yep, that arm's okay as well. Lucky last. How's that? All 100%. So we'll reassemble those. We'll put those back together. And we'll do a little bit of further testing. I've just got the old texture out. I'll put a little gold mark on each of the arms, and we're just going to move the amplitude up and down, change those attenuators. You can see all those arms popping in and out, so it all seems to be working fine. So what we'll do is we'll check for an output on the oscilloscope and see if anything's changed. But first I had better plug it in. And if we can have a look on our oscilloscope, got our signal back, we'll just crank up the amplitude and just get those attenuators to kick in. You can see that signal is getting bigger. Hey, it's not perfect, but you got to remember the chassis is all open. But no, that's at least I've got a bit of an output now, so that looks better than it was before. Whilst I'm putting everything back together, in the next episode we are going to check out the keyboard and see if we can fix any dodgy front panel keys. Don't forget to check out all the videos in this series in the description down below when they become available. If you're interested in seeing other stuff repaired, check out the rest of our channel. Don't forget to share, like, subscribe. Other than that, we'll see you next time in the lab.